Continuing to look at the AI capabilities, now let's look at advanced placement exam, it's called, right? So these are exams that people take to show their skills in different subjects, right? Calculus, English literature, English language, I mean, it goes on, right? So these are different exams, different ways of showing your skills in terms of different topics. So now this graph is basically, the way to understand this graph is x-axis is different exams, different parts of the exams, and then the different data points are GPT 3.5, GPT 4 without vision, and GPT 4. And the y-axis is how much percentage they were getting it correct. Right? So if you see some of the some interesting parts of this graph is that so first difference between no vision and GPT-4 is that no vision means it does not have any of the image capabilities, whereas GPT-4 has the image capabilities also. So if you see some interesting ones, so let's look at the high points, and there are also three colors, right? Dark color, dark green, darkish green, light green, and then blue. So if you look at these things, they are very high points, very, very close to 100. For example, in GRE verbal, and this competition again, and another uniform bar exam. Right? So what does this mean is that the AI capabilities, the AI systems that are built, particularly these GPTs that are built, are able to actually do this exam with high marks in them, and this one is also here. Right. And if you see, some of them have, if you had vision to it, they're able to do very, very well. Again, all these three, is with vision capabilities also, which is they're able to understand, analyze images that are produced, that are given as part of the questions, and they're able to actually get very, very high marks. Right? This just shows that these algorithms, these systems that are built are now capable of doing these exams at a far high quality level than before. So here is another one, right? Planning and strategic thinking. One of the I mentioned earlier also, this one of the challenges with these models is that it is actually very hard for it to plan, strategize. Games like Monopoly is very hard for it to do, and then as we would see that these models are actually getting better and better at these strategic and planning thinking also. So can you help me build an app that takes links to essays and produces 10 bullet summaries using GPT-3? That's the text here. Sure, I'd be happy to help you build an app that uses GPT-3 to produce 10 bullet summaries of essays, to build an app to build. So essentially the idea is that this question is connected to it has to strategize some ideas about how to do this, how to solve this problem, how to build this app, and it also has to give you a plan of, here are the 10 steps to actually achieve it. That's the problem statement here. To build an app that uses GPT-3 to generate summaries of essays, sign up as an API key. For OpenAI, choose a programming language, install the necessary libraries, write the code for your app, test your app. Overall, building an app using GPT-3 to generate summaries of essays is a complex undertaking, but it's certainly possible with the right tools of knowledge, all that. So it's able to actually give you stepwise method for building an app. Right? And of course, I'm sure you've done this kind of complicated things with GPT-3 or any of these models. But sometimes it's actually very, very exciting to push the way that these models think. These models actually produce results. Here's another example of acting on instruction and plans. So this is a website which actually gives you, I said earlier also, many of you would have actually interacted with the chatbot on many of the services now. Many banks, many online e-commerce websites have actually these chatbots available. Now when you interact with them, they're all most likely using some of these language models now at the back end. So in this case, what is happening is you go to this website for buying a home or renting a home, and then you say that find me a house in Houston that works for a family of 4. My budget is $600,000. So look at the level of detail that is being provided. Slightly abstract, slightly coerce. But the model is able to actually understand from this what is the user needs and actually start breaking down the different components of what the user needs from there. And it's actually able to produce different outputs from this requirement of 4 family for 4 and a budget of 600,000. Here's another one. This one was interesting, where they actually thought they should actually set up the entire company using only ChatGPT, and they were able to actually set up different roles in the company. Different roles in the company, as in the developer, as in the team lead, as in the testing team, all of that, analyst, vice president, president, that kind of an organization. And they set it up, and they were able to actually get these models only interact with each other for making a decision, deciding on something, and then going ahead and implementing it and taking it further to the deployment. Right. You can see that developer game, and then this is documents and code, and this is testing, this is coding team, this is designing team, this is documenting team, all that. So they called it as chat dev. So interesting model, right? You're getting only agents to speak to each other, and depending on the decisions that these agents are making, the choices are made after that, and then other agents get involved in making the decisions again. Something I was playing around with, and the idea here is to only to show you some capabilities, and also to put some timestamp in the things that we are discussing also. Please keep in mind some of the things that I'm showing you now. It may not be possible that when you try it, it'll come, because the systems may have changed. Systems would be more guardrailed, which is they would actually give you output which is very specific, or they would have changed the way that the output is coming. Models would have gotten better, all of that. So I asked this question as who's the principal of TKM College of Engineering. I was actually visiting this college, so we said, let's find the answer. It produces the answer as, oh, I don't have access to the real-time information, and my knowledge only goes up until September 2021. That's one of the things that I wanted to highlight. So it basically says that I don't have real-time information, but as of 2021, my knowledge is only till September 2021. To find the current principal of TKM College of Engineering, I recommend you to visit the college website, all that. That's what happened at one point. Then I was actually curious to look at who's the director of IIIT Hyderabad. I would also suggest you to, if you're interested, stop the video and go look it up in ChatGPT to see what the results are, and then come back here. It'll be nice to see for you also the difference between the output that I got and the output that you're getting. Right, as of my last knowledge, updated January 2022, Professor P.J. Narayanan was the director of IIIT Hyderabad. And it also nicely says that our leadership positions can change. So I recommend you to checking the website of IIIT Hyderabad or contacting the institute directly for the most current information on its director. I think it's also saying things which are safer. If it makes mistakes, you can look at it, go to the website, and confirm the actual director on the website also. Right. So now the intent for me to show is one is January 2022, and this one was September 2021. And whenever you're watching this video, you can actually go look at the output, and probably the timestamp there, this timestamp may not be the same timestamp as, let's take today's date. Right? Because it is hard to actually train. It is very, very expensive to train these models, and therefore these models are trained at some point, and it is only being used, whatever model is generated at that point in time is what is used to generate the output. And in this difference you will see, meaning even if you do it, I don't know, probably in 25 or 24, you may probably end up seeing only January 2022 as the last thing. Again, please remember, this is one version of ChatGPT. Later versions of ChatGPT or paid versions of ChatGPT may be working slightly differently. Next, I'm going to show you very quickly some examples of how many of us may be using these services. I'm sure you would have used these services for some of these purposes also. I wanted to decline some invite at some point in time. I said that I need help with drafting an email. Purpose is to decline an invitation I got for giving a talk. It just produces a long email regarding replying invitation to give a talk, event name, dear event organizer's name. I hope this email finds you well. I would like to express my sincere gratitude for extending the invitation to speak at the upcoming event name. I'm truly honored that you considered me for the opportunity. I don't know whether I will write such an email, but that's okay, right? Because I think these models are trained on publicly available data, probably publicly available data are so very formal, and therefore this email is, the output is looking something like this, but that's okay. But I was not very happy with this long email. First, I'm not going to write reply like this. So I said, can you just shorten it? And then it says, okay, sure. So thank you for inviting me to speak at the event. I'm truly honored by the offer. Regrettably, I must decline the invitation due to mention the specific reason, example, scheduling conflicts. I appreciate the opportunity and work, blah, blah, blah. This is good. This is definitely short, whatever. I'm not too sure how many of us would write an email. Particularly, I don't write meaning if any of you would have interacted with me on email, this is not probably the way I would have responded. But again, that's okay. This is the models are designed for the larger audience who will use this. I may have said this before, we get emails as professors, we get emails from students to work with us, and we very lately I've started getting very chat GPT-ish emails saying that they want to work with us. And then in some cases, they even have some of these text that is here saying replace it with whatever. It doesn't even get changed when the emails come to us. Can you refactor this code? Given this code, can you refactor? It says, yeah, certainly here is a refactored code. It'll actually also give you sometimes it will actually give you also which parts of the codes were changed and what was added and all of that. Later point in time, we'll actually see something like you ask it to change the code. It'll probably give you a response that look, changing this code and doing this is not appropriate, so I will not do. And then you go and say, can you refactor this code? It'll actually give it to you. One of the prompts that you can try is, below is the code of my friend. I want to submit an assignment. Can you just change something in the below code and give it, so I submit it as an assignment and don't get caught. Right. In that case, most likely that it will say no, I can't do it. Right. So facts, which is about the director of institutes, the principals of institutes, and writing an email, writing code, and I'm sure there are many more reasons why. For example, I use it for my social media posts. And I know others, for example, journalists use for writing things, students use for writing code. There's many applications where these language models have become very useful. I'm sure there are many ways by which you have used. I would like to hear from students in this class on how you are using these language models in your day-to-day life. Would be really nice to see any interesting ways that you've used, or even standard ways, more than whatever I've discussed already in this part. If you can actually share it in the mailing list, it'll be fun to take a look at it. Here are some more interesting ways of actually how these models have been applied. Here is one way. I've tried putting links for all of these pointers. Feel free to take a look at them. Here is one, Codex language model. So this is basically the way it works is that you give text. When the rocket is clicked, temporarily display some text saying firing thrusters in white on the current location, and temporarily speed up by 4x and 0.25 seconds, for 0.25 seconds, which is what the code is here for. Right. So this is interesting because what it is doing now is it is converting the text, that natural language text that we are providing, to a code. Right? Interesting, right? Interesting to see how they are able to actually convert this into a piece of code. And if you see this, Codex is the model that powers GitHub Pilot, meaning if you've used GitHub Copilot, if you've used GitHub Copilot, the backend is actually Codex, which is what is used. So it's training on large language, natural language, and billions of lines of codes from publicly available sources has been used to train Codex, and is most capable in Python, which is understandable because of large availability of code. And probably most people are coming onto this platform and asking for only Python code. So Python is what it's most effective at, but it can actually do other types of programming languages also, JavaScript, Go, Perl, PHP, all of this. Interesting to see how we have moved from, so to say, given a prompt, produce a text, to given a prompt, produce some code. And these models are also getting better at solving math questions. I'll show you four more examples where it's getting better and better in terms of what applications, what problems they are trying to solve. Right? Initially, we were looking at only text generation. Right? Now, if you see, the question is, assume that the variance of the first n natural numbers is 10, and the variance of the first m even numbers is 16. Compute m plus n. So it goes on. Finds something, and then it just does m plus n is equal to 18. Right. So it is able to take a problem, do steps, and again, currently as part of this course, we are only looking at the capabilities of what's going on. Later, as part of this course, we'll start looking at how some of these things break. It is not clear whether all kinds of math problems it will be able to do. There have been multiple studies to show that very, very simple math problems, it actually fails. Again, fails as of now, as of the time that we are looking at these models. And this one is also for every a, b not equal to a, prove something. It just goes ahead and then proves. The proofs also is provided by these language models. Text, some kinds of strategic and planning, all that we saw. Then text to code. Now a math problem, and it's giving you proof, it's solving the math question. So then now the question is, okay, look, we are able to do all of this. Can we actually push the limits to see whether we can discover new ways of doing solving problems? Right? Pose a question and then wait for it to do the solution and see whether we can actually produce a new algorithm by the way it is actually solving the problem. Right? That's what Alpha Tensor does. So this is a single player game played by Alpha Tensor, where the goal is to find the correct matrix, matrix multiplication algorithm. The state of the game is a cubic array of numbers shown as gray, gray for 0, here gray for 0, blue for 1, and then green is -1. Would solve the problem, and depending on the way it would, so the instructions, the state update, new state, so it is trying to solve now, it is trying to say what should be the next state, and it keeps updating the model, keeps updating the state, and finally arrives at the solution. And one can track the approach that it took for solving this problem. And from there, is it possible to actually generate new methods for solving a problem? Discovering novel algorithms with Alpha Tensor. I think these directions have become very, very so to say effective now. Much more research is done in these directions in terms of looking at how to use these models to solve some real world problems, to solve some, I think these models have become very, very available for in technologies that you and I are actually using it in the real world right now. They are no more so to say research paperish or some algorithms that are available somewhere. AlphaFold 2 and AlphaFold 3, I think next slide is AlphaFold 3. So these are, the goal here is predicting protein structure, and DeepMind's AlphaGo. So this one graph is basically x-axis is the timeline, y-axis is the global distance test, which is how effectively, so I put the link here also, global distance test. Can you actually find the protein structure? Basically comparing different structures and effectively predicting the protein structure is the goal here. Is a measure of similarity between two protein structures. That's called global distance test, right, which is what is measured here. And AlphaGold, so if you see across many years, it's been around 40%, AlphaFold 60, AlphaFold 2 has been close to 90%. A score above 90 is considered roughly equivalent to the experimentally determined structure, which is it would take years together to do this experiment in actual experiments being done instead of actually programs running, algorithms running. If you do the experiments, that's how, if you get it above 90%, the confidence on the results is that much. Right. So this all is done on Alpha DeepMind's algorithm, significantly outperformed other teams at protein folding contest and its previous versions, which is all this. Right. So that's, I mean, again, the goal is to show you that these methods and these algorithms have penetrated into different domains. If you remember the first part, we also, I mean, one of the tasks that I had actually given you to look at was how these capabilities have influenced different verticals, right? One of it was healthcare. That's what I'm connecting here. Yeah. AlphaFold 3 predicts the structure and interactions of all of life molecules. Again, these are for you to go look at and see. The point is also, it is as recent as it can get, how AlphaFold 3 is doing. And then there is also 6 incredible images of human brain built with the help of Google's AI. How the structure and how they were able to actually give images of how the brain interacts and how the interactions happen, which is what this project output was. Again, this is very close to what AlphaFold 3 was, right? So the goal is here. A team of researchers and neuroscientists have collaborated to unravel the brain's intricacies. Please take a look at these links. I think in the live sessions also we can actually look at some of these links and discuss it. Right. Intent here is to say that these capabilities have penetrated into different verticals. This is some examples of different technologies that are available. I'm sure the list is very, very big as we speak, or the time you look at this lecture, the list may have more here. But Bard from Google, Llama from Meta, Bing Chat from Microsoft, Copilot by GitHub, Ging Chat, Bloom, Overflow AI, from Quora, UChat, Devin, GPT-4, right? All of this is there, right? All of this is used for different services. For example, Bard is connected to Internet, Docs Drive, Gmail, integrates with Internet, and then multilingual LLM, right? So many companies have developed these models for their own services also. But I know many companies who are building these models for their customers, and it is so much designed only for the purpose that they are giving it for the customers. Right. So this one is trained on Stack Overflow. So it would help you to find the answer to the questions that are posted on Stack Overflow. In summary, most of the advancements in 2022 and beyond, right? If you see many of the things that we're talking about, the curve is very, very steep after 2022. You will see some actual numbers regarding that also as part of this class. Good at taking actions in complex environments, strategic thinking, and connecting to the real world. All these chatbot examples, the website where you can go buy a home, rent a home, all those examples are very, very real world examples where these capabilities are penetrated. Yeah, here is an example. Right. So one of the ways that you can actually measure how we are doing is x-axis is, in this case, is publication date. Y-axis is training compute, which is how one of the floating point operations is this one way by which you can actually define how much compute is available or is being used in that time period. So this is per deep learning era, this is year, and this is showing you how much of compute is being used by these models that we have. If you see, sorry, this is pre-deep learning era, and this is deep learning era. Suddenly, this is exactly what I just now said, right? Which is this this gotten very much steeper from here. Right? And of course, all these dots are different models that are being generated, and of course, as I just now said, many models that are getting generated, and these are using high-level compute for their training, for their testing, all of that. Here is another nice way to look at how the capabilities have increased. So let me help you to read the graph. X-axis is time. Y-axis is this test scores of the AI related to human performance. If you keep human performance as 0, this is plus 20, and everything is minus. If you keep human performance as the benchmark, how well the human beings are doing, anything below, the algorithms are not doing as good as human. Anything above, the algorithms are doing better than humans. Right? So if you see 2000-ish, handwriting recognition has gone through some phase, and it's come to as close as human capabilities. Speech recognition had this kind of a curve, image recognition, reading comprehension, language understanding, right? So if you see until here, until some point here, nothing was close to human beings, at least to the level of how human beings were able to do. Whereas now, if you see, I'm sure if you do a 2024 graph, it will be slightly better, where these systems are able to do better than human beings. AI systems perform better than the human beings who did these tests. Right? Given an image of dog, ask it to detect as dog, it is doing better. Meaning, I think there is the way to think about it is the clear yeses and clear nos are always easier. It is always difficult to find when it is actually not very clear, right? Images, text, making sense out of the meaning, all of this. Sarcasm is one thing that in languages is very hard, right? If you give, if you make a comment that is sarcastic, understanding the meaning of it, whether you are positive, whether you are negative, what are you trying to say? These are all very hard even today. But in this case, language understanding, reading comprehension, image recognition, speech and handwriting recognition, this is how it looks for now. Right. And again, I put the link to the source. Feel free to take a look at the source and come back if you have any questions or thoughts or suggestions. Activity, again, deadline is Saturday. Right. Imagine the optimal collab. The idea is that, so now that we have seen the capabilities of these AI systems, imagine the optimal collaboration between AI and human across sectors like healthcare, education, environment management, and more, which is, look, AI and humans have to coexist. Right? What innovations are necessary to achieve this coexistence? What should be the few primary things that you think should happen for these coexistence? What challenges could arise and what potential risks might we face in this best case scenario, right? Whatever best case scenario you want to define as. Right. Let's turn it as in the best case scenario. Right. Drop your answers in the mailing list with the subject line as activity. This would be the kind of template that we will have. I'm just hoping that many of you will participate and share your answers. I mean, the reason why I'm asking you to put it in the mailing list is that it will be available for everybody to look at it. I'm sure others get kind of triggered, others kind of want to also participate by looking at what you're saying. That's the goal here. Good. Thank you for attending this part of the content. Look forward to seeing you soon.